off the Kleenex boxes. Okay. Did you find one, Harper? Did you find one, Harper?
10 on the, or we can get one that's.
We have a little packet. The only one done in the packet, I think, is
We did 3, so we can do 2.
2. All right, so we'll look at, this is in our review packet, extra practice linear programming packet, and it's problem number 2. And we got, what is it here?
Is this what the tables look like? It has stuff. These are ABCs of 3.
Okay. So we own a small parking lot. We charge $25 for cars and $100 for buses. Cars occupy 8 meters of space. See what I'm doing here, Harper?
Yeah, are you gonna write the words on?
Yes, I already told you that. Buses take up 25 meters of space. New York has set a limit of 50 vehicles. So the total number of vehicles I can park is 50, and my total lot is 655. Now, what am I trying to do? This one's weird, down at the bottom is a question. I want to maximize my profit. And how will I calculate my profit? 25x plus 100y. Now, what do x and y stand for? The number of cars and buses? Now, what am I going to be graphing? In a minute, I'm going to be sketching. What am I going to be sketching? What are my constraints? X plus y has to be what? Not equal to 50. Less than equal to 50. What else am I going to be graphing? 8x plus 25y is less than or equal to 655. Kids, you only have 655 meters of parking lot. So whatever the cars and buses are taking up has to be less than that, right? And x and y are both positive because obviously we can't have negative cars.
Those always going to be extra.
What do x and y always they stand for real life things, right? Vitamins, whatever. Okay, so now I'm ready to graph this. These are quite large numbers, so I think, oh, they've got a scale on there. I do not have a scale, I can't remember actually. I would use 10s. Looks like they got 5s on there, so that'll be fine. So 5, 5, 10. 50. First one. Here's my second one. So this is going to be my black equation. X plus y is 50. So there I go. And where am I shaded? Underneath. So this triangle right here so far. Now, in purple, probably going to get some decimals here, right? Can it? 655 divided by 8. So this is going to be, cover up y. X is going to be 81.8. covered up X and got 26.2, covered up Y and got 81.9. Connected those, and they would also be shaded underneath. So, here are the corners of my shading. So I have 0, 0, 0, 26.2, 50, 0, and then this guy. With all the decimals in this problem, I don't think I'd be trying to eyeball that. How? I'm gonna substitute or eliminate this equation, right? So x plus y is 50. 8x plus 25y is 655. You could easily substitute on this one. I think I'm going to eliminate. I'm going to multiply by -8. So 17y equals 255. So what's 17? Oh my gosh, it came out. Wow. So if y is 15, then x is 35. All right, everybody still with me here? So these are my options. I want to know which one is going to get me the most money. So obviously, if I park no cars, I make no money. What if I park 26.2 buses? Well, that'll be 2620, right? Wait a second. Can I park 26.2 buses? No. I'm gonna have to make that 0.26, aren't I? And so this will be 2,600. Some things we can do in practical, like yesterday we had a half a pill. We can do that. But you're not gonna have a 0.2 bus. So we're just gonna have to get rid of that. 26 buses. All right, 50 cars would be 1,250. And then 35 cars and 15 is 2375.
Winner,
Sean? That's not our winner.
0.26.
What's our winner?
Oh, wait.
Forget the cars and park 26 buses in your lot. Now, that may not be a very good business decision. I mean, in terms of keeping customers happy, but in terms of making money, that's what you're gonna do. 26 buses, $2,600.
Can we do a graphing one with like the acid?
Yeah, so let's go back to pretest number 2. That's where we were focusing. And that would be on pretest number 2, which we started yesterday, and you were supposed to spend some time with last night. That would be a question like number 9.
Yeah.
So let's just start putting stuff in. What do we know we have in our picture? We know we have a horizontal asymptote, and where is that? At y equals 2. Because horizontal asymptotes come from this, right? What else do I have in my picture? I have a vertical asymptote at 3, because vertical asymptotes come from the denominator being 0. So that would be 3.
No, on the X, you got -1/2.
So my x-intercept is going to be at -1/2 because x-intercepts come from what makes the numerator zero. They're called zeros. The numerator is zero. The fraction is zero. So -1/2. What about my y-intercept?
-3.
-1/3. Because we get x or y-intercept by letting x be 0. There are no holes in this problem because nothing's canceling. So we're done, except for the shape. So it looks like we got these two guys. And then so we good on this? Jimmy?
Yeah.
Alright. Now, which one do you want?
Wait, for the solving, are there inverse ones, or are we gonna do that with your calculator?
No, on the calculator, you're exactly going to do. There's one calculator problem. Yeah.
Okay, but can we do one solving inverse?
So, inverse method, we're gonna do it by hand. So that would be problem 6. We haven't done this yet. So problem 6 says solve using the inverse method. Alright, so we did this yesterday. First thing you have to do is find the you gotta find the inverse of your coefficient matrix. And as Michael just said, those are the coefficients, right? To find the inverse, you need to find the determinant. You need the determinant. So the determinant of that will be -5. -3 minus 2. Okay? Then,
We just do the coefficients.
sorry, square matrix.
Yeah, okay.
Alright, so then, you build a new matrix by flip-flopping these and changing the signs on those. Then we take that new matrix and divide everything by -5. That's the inverse. So if you were in another question on the rest of the test and it said find the inverse, that would be it after you simplify. So I simplify 3/5, 1/5, 2/5, -1/5. Okay, so if my job were just to find the inverse, that would be it. That's the inverse. But I'm using the inverse to solve the system. So I take this guy right here that I just found, and I multiply them by those numbers. So here's the inverse I just found. I'm multiplying him by these numbers. So it's a 2x2 and a 2x1. This is going to be another 2x1. So 2 rows, 1 column.
So then you bring in the
These times these. So 3/5 and 1/5 times 5 and
still find the inverse.
no, here's the inverse.
Yeah, that's what
Then I multiply it by those, and that's how I get my answer.
yeah, that's what I'm saying. Still find the same.
I'm multiplying. I multiply these two together.
Same problem that we were.
Yes,
This
yes,
is
yes,
the
yes.
same problem. So I've got 15 minus 5 10/5, I got 2. 15 3/5 minus 5/5.
So that's 3 minus.
Then 2/5 times 5, You tell me what problem you're talking about.
Number 2.
So are we done with this one?
Oh,
Problem
three.
two has nothing to do with this. I don't know what you're talking about. Hang on to that.
7K.
7K. Well, we gotta remember what that TR out in front means. Yesterday, we looked at one that had a superscript like an exponent T. This has a TR out in front, and matrix A is 1 negative 0.5. Yes, that's there. So who remembers what that TR out in front means?
Trace.
And what does that mean? Oh, no, that's transpose.
Oh,
That's transpose. And I remember what trace
it's the,
means?
you add the main
Add those up, that is exactly right. So I add up these numbers right here. Not that one. Right here. So 1 plus 1 plus 5, so the answer would be 7. That's all it's trying to say. All right, Brady, did you figure out what the problem you're talking about now? Number 3. Now we're gonna solve using Kramer's. Okay? Here we go. First thing we do is find a determinant of the coefficients. Just like we did with our inverse. We start the same way. So that determinant will be 13. Under the Kramer's. Now I need 2 more determinants. And they're gonna look just like this one. These are the x's, these are the y's. Except when I'm solving for x, I plug those in for x. So 8 negative 7. My y's stay the same. And then when I'm solving for y, I plug those in for y. So my x's stay the same, and I have new y's. Then I evaluate those, so that's going to be 30 minus 19. And remember, that goes over the 13. So that's 19/13. And negative 22. Okay? All right, you have time for one more, and then we're going to do the calculator part of our test, which is just a couple of problems. All right, one more. Hand up.
We'll roll. I'm ready to rock and roll.
Oh, never mind.
You just looked at 7C or 7D. Like that D and
Should've did
Well,
that.
actually, C is in the square matrix, so that's not very possible. And the determinant of A, how do we find the determinant of a 3 by 3?
You gotta add the first 2 columns and then
We tack on the first 2 columns.
Really?
All right, let's get our dividers up and our calculators out.
add or subtract this.
All the ones that go the same. It is your turn. You multiply and add them up.
everyone's already has that.
That's how it was last time we did this?
It's annoying, because then it's so rewarding finishing.
He's what, 27 years old?
We need to finish the portion of the test.
Yes.
What
Trying to
time
do
is
that.
that?
That's my Instagram account.
Can't wait for his down here.
All the time.
There's so many. Royce, you're a Nike fan now?
They hit me at a good time.
Oh, definitely.
You see Mark,
These
you
are
see
graphic
Mark
cards.
Leonard's
Yes.
It was good. It was good. Everybody getting good
You are
conversation.
grabbing calculator. No. Here we go.
Yeah.
This page has two sides. Using both sides of this page. Focus, focus. Both sides of the page. This is calculating, the whole thing is calculating. The paper I'm giving you, you're gonna use your graphing calculator.
Wait.
Did you get birthday bonus?
I didn't know.
It's a test. You're allowed to use all the tests.
No, I am.
Oh, you're not?
And we're only doing, we're gonna calculate it before lunch? Okay.
This is the only thing we're doing till 12:25.
The yellow something.
Yes. This piece of paper.
I think you're right.
That's good.
Everyone's here for the test day.
Everybody is doing the word problem and the calculator problem before lunch. 12:25.